Another way of saying this is we often try to think of the brain as a muscle, right? We're either flexing it or we're letting it go. But in reality, what the brain is always, always, always flexed. Okay? And so what we're going to do now is just take a break, and we're going to do a little activity where you guys get to use some of this spontaneous activity based on that is really important for maintaining attention. A lot of folks, undoubtedly, in your classrooms, I'm sure all the kids in all the classrooms are perfectly attentive all the time, and they're always listening exactly what you're doing. But for those cases that they're not, this hopefully what this experiment will show is that maintaining critical attention is extremely difficult, even for adults, and particularly for children. That maintaining that type of attention is dependent on some of the stuff, this percolating information that's going along in the background. And this game called MindFlex gives you an example of that. What this game does is it provides, essentially you put on a headband, and it's something that's kind of fun to play with a lot of kids. A lot of the outreach events that we do, we use this game to kind of talk about the type of information that we're getting from MRI because it's fun. And so what happens is it's essentially a headband that has two electrodes on your head, which kind of measures your brain activity, the spontaneous stuff that's happening in the background. Now this spontaneous information changes as you attend more to something versus you don't. Doesn't mean it doesn't go down, it just changes. And we can monitor that change, and what this game called MindFlex does, monitor that change and allows you to move a ball either up or down or front or back, depending on how well you're attending. Okay? So what we're going to do now is everybody's going to split off into 3 groups. You guys get to duel against each other to see who's got the best attention, and play this game. You get a sense of how some of this information it can be used to pay attention. It also can be used to play fun games like this. Now, when you put it on, you're going to put it on like this, and this dot right here has got to be right above your left eye. Okay? And then you put this little, we'll help you with this, but you'll put this little guy in your left earlobe like this. And then what you have to do right now is you're going to try to attend as much as you can right on the ball. Okay? And you just watch it and really try to focus hard. You'll start learning what it means to, as you go, you'll start learning.
Are you trying to like imagine it like moving?
Yeah, all types of, anything it takes you to really attend to the ball. Ooh, she's coming back. You can see the attention here. Ooh, she's really pushing it now. She's got it. You can see. Oh. Okay, let's see here.
I think you have to attach this to your ear.
Calibrate.
You literally just think about moving it. All right.
Right. So there's a couple things here. First is it wasn't working for everybody, and I was trying to figure out why it wasn't working for everybody, because it works on me every time. And I figured it out. It's because some of you have lots of hair, and I don't. and so the hair makes it hard for the electrodes to pick up the signal, the brain signals. So that's why it wasn't working for everybody. It did work for some people, and we just tested it. We pushed back your hair, it seemed to work okay. But I didn't catch that at the beginning. But what this is measuring, it has 2 essential electrodes. Have anybody ever seen an EEG before? So EEG what it's measuring is really fast signals that are kind of oscillating on time. There's different frequency domains, and so like slow frequencies where there's oscillations that are really slow, brain signals, and there's some that are really fast. And this one is likely what's happening is it's measuring the power in some of those signals. And what that means by power, it means it's almost like the amplitude of these spontaneous signals. So when you're in specific frequency ranges, when you're attending more intently, the power distribution or how the amplitude of these spontaneous signals changes, and that's what they're measuring to make it either go forward or backward or up, with the wind or down. That's what this particular machine is measuring. Yeah, no, it's the same principles. So it turns out that the types of signals that we get out of the fMRI machine they're based on the signals that we're getting out of this or an EEG or this game. They're related, but it's not the exact same type of signal. And so it's based on the same principle. That's exactly right. It's almost like training in the case of ADHD, like the last question. But they're just slightly different. But this is a good example of the types of stuff that we can do with that fMRI. In fact, there's some recent work now, you mentioned pain, that shows that these fMRI, these spontaneous signals that you measure with fMRI, are a good marker for how much pain a person is actually experiencing. So there's a lot of work in that realm for sure. The short answer is yes, you can be, for this particular game, you can be attendant to anything. Now, this is just a game, and now in the neuroscience world, there is much more sophisticated and expansive ways to do this, almost this exact same thing to help folks who have been had spinal cord injuries, or trying to move an arm, or trying to manipulate a computer screen or a mouse, where you can actually get a lot more information out of these types of signals to do much more specific things. Like, well, in that case, in those cases, you depend on what you're attending on or what the specifics. For this particular game, it wouldn't matter. Anything that you're attending to. Now, the reason why I said that was difficult to answer was because you were saying attending to a frog inside my head. Now, internal representations or internal daydreaming, that's different than attending to the external world. If you guys take this back in a classroom or something like that, where you're trying to teach kids about some of these signals that are happening in the brain. One of the tricks that I did when I was actually playing this with my son last night before I flew out here, who's 8. And what I was doing was reading a book, and then not reading a book and just trying to kind of shift my focus over across the room. And it helped me kind of learn how to manipulate the attentional signal. So if I was reading a book and really understanding the words, it requires deep attention, and that changes. It makes it go forward or back. But when I was shifting my attention from different things, then because you're not focusing on one little thing, that it kind of goes down. Relaxing is another way to do it, but it's, again, you have to, learning how to not to attend to something is a very difficult thing to do. And so it's hard to actually learn how to make this thing go up and down. But it's also a good example of how difficult, and it would have been easier to see if everybody had a chance to have a good experience with it, but it gives you how hard it can be actually to attend to one thing when you're sitting down, for example, in a classroom. It's hard to maintain it for over long periods of time to really integrate it. So it's an example to help folks learn about those kind of processes. That's a great question, and the answer to that is not known for sure yet, but there are some ongoing studies that are testing that. Not necessarily with this particular game, but with other kind of behavioral interventions that mimic kind of like a repetition of paying attention, or attentional tasks to help kids, help them learn how to attend more. That's exactly what a lot of people are doing right now, and looking at. Absolutely, that's absolutely. This is actually an ongoing. That particular question is work ongoing even in my own laboratory. We're examining kids with autism using various signals to see how the functional organization of the brain might be unique relative to a typically developing child, which may help us understand things like, how they process or how they attend to social scenarios, for example, like facial patterns and things of that nature. But absolutely, that's exactly what we're trying to work. That's absolutely what's happening right now. Now, is there a definitive diagnostic test using these measurements? The answer is no. But is this work that's ongoing, which is showing a lot of promise? The answer is yes.